Alright students, we are going to continue our lesson of trigonometry, and in this lesson we're going to specifically focus on angles of elevation and depression. This is part 2 of lesson 7.5 and 7.6. Okay, so most of this is just reading, and I'll read out loud if you'll follow along. Many problems in daily life can be solved using the trigonometric ratios sine, cosine, and tangent. Remember to use the trig, and here's a typo, so if you'll fix it please. It shouldn't say rations, it should say ratios, so take out the N. We need to have right triangles. This only works for right triangles because trigonometry is the study of right triangles. Oftentimes, these problems involve an angle of elevation or an angle of depression. While working these problems, it is imperative that you draw and label a diagram. Okay, so I want you to highlight that. While working this problem, it is imperative that you draw and label a diagram. So don't tell me, but Miss Ollmann, you didn't tell us we had to draw the picture. Yes, I did. Angle of elevation. The angle of elevation is always measured from the ground or a horizontal line up. Think of it like an elevator that only goes up. Okay, you need to highlight this as well. It is always inside the triangle. So here, from the ground up, it's our line of sight as we move our eyes up to see the top of the tree right there. Okay, so this is always, see how it's inside the triangle? In the diagram at the left, X marks the angle of elevation from the ground to the top of the tree. You can think of an angle of elevation in relation to the movement of your eyes. You are looking straight ahead and you must raise or elevate your eyes to see the top of the tree. Alright, next, angle of depression. The angle of depression is always measured from a horizontal line down. It is always outside the triangle, right here. See the triangle here? This is outside the triangle. It is never inside the triangle. In the diagram at the right, X marks the angle of depression of a boat at sea from the top of the lighthouse. You can think of an angle of depression in relation to the movement of your eyes. You are standing at the top of the lighthouse looking straight ahead. So this is your line of vision, your line of sight right here. And you must look down to see the ship. You must lower or depress your eyes to see the boat in the water. Okay. What do you notice about the angle of elevation and the angle of depression in the figure below? Okay, so here, remember, angle of elevation is in pink. It's here. Angle of elevation inside the triangle. Angle of elevation, or depression in green, it's outside the triangle here. We should notice that they are congruent, so let's write that down. The angle of elevation and the angle of depression are congruent. Okay, now it says, why are they congruent? Take a very close look at the picture that we have here, and you will notice that you have two lines, your line of sight and the ground. We think of those as two parallel lines. So let's mark that with the parallel symbol. These lines are parallel. Okay, well, if these two lines are parallel and they're cut by a transversal, that makes these two angles what kind of angles? Yes, they are congruent because they are alternate interior angles. They are congruent because they are alternate interior angles. And we know that all alternate interior angles are congruent when these lines are parallel. Okay, next page. Now this page is all of our examples, and we only have 4 of them, but it's going to take a little time because we have to actually draw the picture. Okay, the angle of elevation from point A to the edge of a cliff is 38 degrees. If point A is 80 feet from the base of the cliff, how high is the cliff? So first of all, I'm going to start by drawing a cliff. A cliff is kind of like a hill that drops off. So here's a line, here's some land, and then it all of a sudden drops off. Okay, and then here's the land below. So right here, this is the cliff. And I'm going to mark that right here with point C for cliff. And then down here, this is going to be point B for the base. And it says that it's going to be 80 feet away from the base of the cliff. So point A is 80 feet from the base of the cliff. So point A is going to be 80 feet away. So this is point A. This forms a right triangle. Alright, so now it says that an angle of elevation, remember, is inside the triangle. So angle, if we're down here and we have to lift our eyes to see the edge of the cliff, that's going to be where the 38 degrees goes. So 38 degrees is this angle right here. Alright, so now we start applying our trig. If this is my angle in question, so this is the red, here's my angle, then this over here, this side over here is what I'm looking for. How high is the cliff? This is the opposite side. This is across from the right angle, so this is my hypotenuse. And this helps make the angle, or it's next to the angle, so we call it the adjacent. Okay, so I don't know anything about the hypotenuse. So I'm just going to list what we know. We know, and you don't have to do this every single time, but this is just going to help you in your notes, if it's in your notes, figure out how to do your homework. So I'm going to list what I know. I know that the opposite is equal to x. I know that the adjacent is equal to 80, and I know that the hypotenuse has no markings, so I have no information about this. So anything that has to deal with the hypotenuse, I don't want to use because it's not going to be helpful. So let's think about SOHCAHTOA that we learned in part 1. SOHCAH and TOA. Anything that has a hypotenuse I can't use. It's not useful for me. So here that's an H, so can't use sine, can't use cosine, so I need to use tangent. So I'm going to put tan 38 over 1 is going to be opposite over adjacent. Opposite is x, adjacent is 80, and I'm going to cross multiply. Okay, so that means that x is going to equal 80 times tangent 38. And when I plug that into my calculator, remember you have to make sure that your calculator is in degrees. So when I plug that into my calculator, I get 62.5029, because remember we want to round. Always round trig. When we're dealing with trig, we always want to round to 4 decimal places or the 10,000th place. So the cliff is 62.5029 feet high. All right, next one. From the top of a tower, the angle of depression to a stake on the ground is 72 degrees. The top of the tower is 80 feet above the ground. How far is the stake from the top of the tower? Okay, I'm going to first of all draw a tower. Okay, I'm just going to draw a tower that looks, here I'm going to label this tower. That's a tower. Here's my ground. And if I'm standing at the top of the tower here and I'm looking out, there's my line of vision, or my line of sight. Okay, so now way out here is a stake in the ground. Okay, stake. It's kind of like a zip line. And we're going to zip all the way down here to the ground. Now we're going to hopefully stop back here so we don't crash into the ground. But what we're trying to do here is figure out how far away the stake is from the tower. So this is what I want to know. Now, what they told me, or what I learned on the previous page, is that my line of sight and the ground, we think of those as parallel lines. Cut by a transversal, that means this angle and this angle are going to be alternate interior angles. They also told me that my angle of depression, remember the angle of depression is always on the outside of the triangle, so that's going to be 72 degrees. So that means that this one down here has to be 72 degrees because these are alternate interior. Okay? And then I know that my tower is how tall? 80 feet. So over here, this is 80 feet. And that's all I have. So now I use my trig. I know this is the opposite. I know this is the hypotenuse. And I know this is the adjacent. This is my angle. That's opposite, that's adjacent. And this is my right angle. Okay, so I'm going to start up here with what I know. We know the following. We know that the opposite is 80. We know that the adjacent is x. And we know that the hypotenuse is a big question mark. So anything dealing with a hypotenuse I can't use. So again, so, ka, and toa, I can't use anything with an h. So sine is out, cosine is out. Oh, I'm sorry. I read that wrong. How far is the stake from the top of the tower? So my x goes here. I want to know how long the zip line is, not how far the stake is from the base of the tower. Oops, my bad. Okay, so these are opposite. Okay, so adjacent is the question mark. That's the one that I can't use. But my hypotenuse is the one is x. Okay, so back over here. This is so, ka, and toa. Anything with an A I can't use. So C-A-H, I can't use that. And T-O-A, I can't use that. So the one I use is sine. Okay, so sine of 72 over 1. Sine is opposite over hypotenuse. So 80, opposite is 80, over hypotenuse is x, and I cross multiply. I get sine 72 times x equals 80 times 1, which is 80. I divide by sine 72. I get x is equal to, here's my exact answer, 80 divided by sine 72. Now I have to plug that into my calculator and round to the nearest 10,000th place. So I should get 84.1170 feet. All right, the next one. You measure the angle of elevation from your eye level 5 feet from the ground. And that's not saying that you're 5 feet tall. That just means from the ground to your eyes are 5 feet. And then you have the top of your head, so you might be 5'2" or 5'4". Okay, so to the top of a light post to be 35 degrees. So the angle of elevation is 35 degrees. If you're standing 20 feet away from the light post, what is its height? Okay, so as we learned in the last example, it's very important to draw the picture correctly. So I'm going to draw a little stick figure over here to represent me. Here's my eyes, and here's my line of vision. And then here's the ground that I'm standing on. And remember, line of vision and ground, they're supposed to be parallel. Okay, here's my fancy dancy light post here. Okay, the light post. There's my light shining out here, shining brightly. And what I want to know is, what is the height of that light post? So I'm looking for this. But my angle of elevation is from my line of sight up to the top of the light post. So this right here is 35 degrees. I know that my height from here to here is 5 feet. And I know that I'm standing 20 feet away from the light post. Remember, this is my line of sight, and this is the ground. Okay, so here's my right triangle up here. It's kind of elevated. So when I get my final answer, remember that I want y. So I need to find x, and I know since this is like a rectangle here, if this is 5, I know this has to be 5 over here. So when I get my final answer, I'm going to add whatever I have here plus 5 to get y. So y, I want to find y, that's what I want to do. And to do that, I have to say y is equal to x plus 5. Okay, so let's remember that. Okay, so now I use my trig, and in my trig I know that this is the opposite side. I know this is the hypotenuse, and this is the adjacent side here. And what do I know about the adjacent side? Well, it's the same as this here. It's 20. Okay, so what do I know? We know that the opposite side is x. I know that the adjacent side is 20, and I know that the hypotenuse is question mark. So again, I don't want the hypotenuse. So if I put so, ka, and toa down, and I scratch through everything with an h, there's an h there, can't use, h there, can't use, that means this time I'm using tangent. So tangent 35 over 1 is going to equal opposite over adjacent. Opposite is x, over adjacent is 20. And I cross multiply. So here, x times 1 is x, and these two I multiply. That's going to be 20 times tan 35. And that's what I plug into my calculator. And so I get x is approximately 14.0042 feet. But remember, that's not my final answer. I want the height of the light post. That's just the height from here to here. So remember, you have to add 5 to it. So y is approximately that 14.0042 plus 5. So y is approximately 19.0042 feet. And there's my answer. Okay, last one. You are standing on the top of a 100-foot hill, excuse me, in Scotland. And you see Nessie, Nessie is a name for the Loch Ness Monster, by the way, in the water below. You measure the angle of depression to his head to be 20 degrees. and the angle of depression to his tail to be 16 degrees. How long is Nessie from head to tail? Okay, so here I'm standing on the hill. Here's a big hill far, far away, and I'm standing up here, and here's my line of sight, and then here's the water. And here's Nessie. Okay, so the angle of depression to Nessie's head is 20 degrees. Since the line of sight and what we consider to be the ground or the line of the water is parallel, I know that this angle right here is 20 degrees. Okay, then over here is Nessie's tail. So Nessie's tail, this is going to be 16 degrees. There's Nessie's tail, pops out of the water there. So this is 16 degrees. So to measure from here to here, what I have is two overlapping triangles. I have a big triangle here. Right here, there's a big triangle with a right angle. This is going to be 16 degrees. And then I have a smaller one. If I separate them, it's going to be 20 degrees. So what I have to do is find this length and find this length. And since Nessie's head is here and his tail is there, what I want to do is subtract those two so I can find this distance here. Okay, so I know this is 100, I know this is 100, I know this one is X, I'm going to call this one Y, and what I want to do to find Z, the distance from the head to tail Z, I'm going to say Z is equal to Y minus X. So we have to remember that. Okay, so now I'm going to use trig. I know that this is, here's my angle here, that's opposite and adjacent, that's opposite and adjacent. So if I'm going to find X, that's going to be tan 20 over 1 equals opposite over adjacent, which is X, cross multiply. That's going to be tan 20 times X equals 100. Divide by tan 20, divide by tangent 20. X is approximately, plug that into my calculator, 274.7477. Okay, so I found X. Now I need to find Y. So that's going to be tangent 16 over 1 equals opposite over adjacent, so that's 100 over Y, cross multiply. I get tangent 16 times Y equals 100 times 1, or 100. Divide by tangent 16. I get Y is approximately, plugging that into my calculator, I get 348.7414. Now remember, I have to subtract these. So plugging those into my calculator, I know that Nessie is approximately 348.7414 minus 274.7477. So Nessie is approximately 300, no, I'm sorry, 73.9937 feet. And I'm sorry, if I saw anything like that in the water, I wouldn't be swimming in that lake. Okay, so that's a big Loch Ness monster for sure. Okay, folks, that is it for angle of elevation and depression. So that is it for notes 7.5 and 7.6.